So I started the recording. Hello, everyone, and welcome to another EESSI Happy Hour session. That is every Monday between 2 and 3 p.m. Today, we're in the topic series of troubleshooting and debugging easy software builds. It's a topic series with a single session. We have already seen something similar earlier, but today we're going to go a bit deeper. I'm just going to remind you that the session is being recorded. So at the end of the session, we're going to stop the recording in case anyone would like to share anything related to EESSI more comfortably. As a reminder for what we have shown in the previous session, before contributing to EESSI with additional software packages, you should always try to check first if you comply with the contribution policy. So I would quickly go over the contribution policy rules. First, the software you are trying to build should be an open source that is basically without being licensed so that we can redistribute it freely. Second, the software package we are trying to build, it should be built by the bot. Third, it should be relying on easy build because we have seen earlier two ways of building software on top of easy, either using the build-env modules or easy build. So to add packages for easy and redistribute them, we rely on easy configs and thus easy build. Fourth, you should be aware of the toolchains supported by each easy version. So, for example, for easy 2023-06, we support the FOSS 2022B, 2023A, and 2023B toolchains. So you have to be aware that the software you are trying to add should comply with those toolchains, and it should be to the recent available version. Also, you should be aware of the CPU microarchitecture you're trying to build. We do make some exceptions in case, for example, the software you are trying to build does not support a specific CPU architecture. But in general, we should be able to build the specific software package on the 14 different architectures that are currently supported by EESSI. So this is in short the contribution policy, and you can further check through the link available. For today, we will be looking deeper into debugging steps for contributors. So usually you make a pull request, as we saw last time, to add a software package on top of EESSI. And for that, we then initiate builds. When things go smooth, basically the package will be built and it will be added to the EESSI stack. But more or less, things are not always smooth and easy. So sometimes the build fails. And usually when it fails for different architectures, it is with the same failure, it's easier to troubleshoot. And if it fails with different errors for different architectures, it gets more complicated. It's also good to know that for you as a contributor, you might not be able to at least regenerate the failure on a specific architecture. For example, if the failure is on an ARM-based architecture, maybe you don't have access to that specific type to troubleshoot or to regenerate the error. In that case, we as EESSI support team and EESSI builders, we will help you to further go forward with your pull request. For debugging failing builds, basically we will be seeing how we do that using the EESSI container. There are several steps you need to keep in mind. First, you need to git clone the EESSI software layer scripts. That will give you access to the EESSI container script which in turn, when you run that, you get access to the easy container. After that, you need to keep in mind that you need to initiate and go or start the Gentoo prefix. The Gentoo prefix usually helps you to use the tools available from the Gentoo instead of from container. Plus, it also adds a layer of isolation. In previous Easy Happy Hour sessions, when we mentioned the topic was how we build software on Easy, we didn't go so deep and we didn't mention the Gentoo prefix. But today, since we want to more or less be in the same situation as the steps we were taken by the bot to build the software, so we need to use the Gentoo prefix. After that, you need to initialize Easy and then load and configure Easy Build, which is done through loading the Easy Extend module. So you have to keep those steps in mind because I will be showing later on and going through them during the live demo. So for that, for example, you can initialize the Easy container, and then you initialize Easy and load the Easy Extend module. I'm mentioning all those because we have seen them earlier. You can check the previous Easy Happy Hour sessions. But for today, I will mention also that during debugging, sometimes you need to go over and over and start the debugging session again. Maybe you stopped at a certain step and you want to also restart or continue what you have started earlier. So for that, I'm not sure if we mentioned those in another Easy Happy Hour session, but the Easy container has some options which you can check with the minus minus help option. And one of them is the minus minus save. We will be seeing that in the live demo. So we will use the minus minus save option to save whichever state we are in and continue from there at the next initialization. Also, we will be covering the singularity cache directory. We also saw that earlier, but I'm mentioning this so that you can be aware while we apply it in the live demo. And finally, we will also mention the minus minus host injections. We usually use the host injections for more advanced MPI injecting libraries. Here we will use it for NVIDIA if and only if the software package you are trying to build is involving some NVIDIA libraries and software packages. Then it is good to have the minus minus host injections mentioned because every time you try to build something which is failing, it will automatically try to download and install a required CUDA libraries and files, which require some space. So instead of doing that over and over, you can use the minus minus host injections. It will download and install the first time, and then it will keep on using the already existing files. So using those, the minus minus save option, the host injections, and the singularity cache directory, you will be debugging efficiently. So instead of wasting time and downloading and installing things over and over, you will only do them the first time. For today, we will be covering the easy install software.sh script. That is the exact script we use for building software using the bot. The easy install software.sh script basically checks the difference that has been added to the easy stack file. That is the contribution PR that you have been adding to add software to easy. And after that, it handles all the management, that is the loading the correct easy build version. It will make sure that the easy stack file exists. It will try to load easy build with the specific settings that we do using the bot. For example, if you try the first way without using the easy install software.sh script, And just by initializing easy through the easy container, you need to make sure that you do that using the -arw, that is to get read-write access to the CVMFS, and then specify that you want to install or build the software on the CVMFS that is available through the overlay. But when you use the easy install software.sh, it will take care of that and it will make sure that it is installing in the CVMFS and in the right CPU microarchitecture location. And finally, I will just mention before going to the live demo that there is a possibility for rebuilding software in Easy, but we usually avoid that because of the dependencies that get installed on top of the package. But in some cases, in really rare cases, we are in need to rebuild, and you can check the link provided um, to see how we do that in case we want to rebuild some software. Lately, we did that for CUDA, but we try to avoid that. So for now, I will try to run the live demo, which I was having some trouble a while ago. And for the live demo, before going there, I need to just clarify that I made a pull request, which is 1295, trying to add Nest, which is a free source software on top of Easy. So I just made a build for the Zen 2, AMD Zen 2 CPU microarchitecture. So for the demo, I will try to build, for example, if it was failing for Haswell or generic, I will try to build the same software on my demo VM. So I will clear this out. This is my Happy Hour VM. I will remind you that in your case, you might be only able to build for the CPU microarchitecture which you have and also for generic. To check how to build for generic, it is available in the Easy Docs, and also we have covered that in previous Easy Happy Hour sessions. So to get access, as we said, to the Easy install script, first we need to do two things. We need to first clone the Easy software layer script repository. And second, we need also to clone the Easy software layer repository where we made the pull request. And now if I go into the software layer, that it has only the main branch. My pull request is still not merged, so I can't see the differences. So what I will do is I will pull the changes, which I showed it was 1295 into a branch called debug. And if I do the git branch now, I can see that the debug is available. Git checkout debug. And if I want to make sure of the changes, let's slash software 2023, which I requested, easy 5.1.2 2023A. And as you can see, those are the changes which I added, which are nest, and it is from a specific commit. So what I will do next is copy this easy stack file and whichever is available, although I don't need them, into the software layer scripts easy stacks. I have a failure. Let me see. Software layer scripts easy stacks. It is there. Let me see. Mm, Let me specify software here. Okay, this should look fine now. And if I do ls, let me go into software layer scripts. And just to make sure that it's copied correctly, so if I do the same thing here, it is software, this should be changed and it should be something like this. Mhm. Yes, it should be copied somewhere here. But anyhow, we can do the troubleshooting and we can see if something went wrong. For now, as I said, so we have cloned the easy software repository. And earlier, I tried to start a session to cache the container image so that it will not be downloaded over and over again. So the command I will be running is singularity cache directory, which basically I used earlier. I have easy common directory earlier. I will show you now where it cached the container image. And then I will use the easy container script. As said, I will use the minus minus access read write because I need a read access to the overlay of slash cmfs. I will use the host injections, not for the NVIDIA, but I will use it now as a temporary space to save, as you're saying, because we are saying that minus minus save easypr directory, and I specified that. I will do that again, just in case. So as you see, if I do like easy common, so if I do ls easy manual builds, which I specified, I can see that there is a host container cache, and here is the image it has downloaded the first time during my first initialization. So my first run, I will run that again now. Mhm. So basically it is pretty fast because it has used the already downloaded image. And what I need to do now is I need to export specific environmental variables, which are, I will tell that I'm using the EasyFMFS repository, which can be anything for you, but for us to troubleshoot, since we're building on top of Easy, so we needed to have it like CVMFS, software.easy.io, which is Easy repository. And we are now troubleshooting something that we are building on top of Easy 2023-06. So I always also will use that. Another thing I will use before starting the Gentoo prefix, I will export the EasyOS type. For now, we only support Linux. And I'm exporting the Easy CPU family. It will auto detect the CPU have in my VM. And all I have to do now is start the Gentoo prefix. So if you see, all I'm doing is that I'm passing the easy repository, which I have defined with the version, and then the compat with what it has detected, which CPU family, and start prefix. So if I do that, it will go into the Gentoo prefix. It has added some more isolation from the container which I'm in. And what I need to do now is, again, export the CVM fast repo and the version. And why is that? Because as I have told you, it adds an isolation and some environmental variables are cleared out. And now if I do that, all I have left is to try to start the easy install script that I said. I will specify one more thing with the minus minus skip CUDA install. So if your pull request or the software you're building doesn't require CUDA, you don't need to add any CUDA or library installation. So you have to specify the minus minus skip CUDA install so that it will not install anything. As you're seeing, it will check, it is doing the same thing as and repeating what we do while we build software. So it checked, it tells you that we're good, we're in the good Gentoo prefix. Now it will try to load an easy build module, then check the PR which you have made and make sure that you're using the same easy build version, and then put some settings for easy build, and then it will automatically try to build. I hope it goes forward. I'm not sure. Uh, so it might take some time. Maybe not to waste more time. We can go to questions and have a look at the end if it has succeeded, failed, or just got stuck. We'll see. So as you can see, for the Zen 2 architecture, it has built successfully. And there you can see some additional information. Yes, Kenneth?
Oh, but one question, I know the answer, but I guess it will help for people here.
Yeah.
You were skipping that CUDA installation. Why would the script install CUDA? The CUDA is already available in the easy repository.
The CUDA is available in the easy repository, but we are, since CUDA is not free and it has licensing, so we cannot ship it. So that's why we require to have CUDA locally installed, and then we link libraries from our installation against the locally available ones so that we don't ship a licensed software.
Yeah, it's mostly about the CUDA compiler. Yeah, we cannot ship the CUDA
Yeah.
compiler in easy. Whenever we need to build any CUDA software, we just do a local installation of CUDA first, which takes some time. And if you don't need this in this debugging scenario, yeah, it makes sense to skip it.
So if anyone has any questions, it's a bit complicated procedure, or might look so as a first look, but we are welcome to help you in case you're troubleshooting any build that you have. And in case you have any questions, clarifications, please go forward. Either post them in the chat or ask them directly. Maybe I can add one thing here. Our documentation needs to be updated, so maybe I will also have a look into that. We continuously try to improve our ways to build software, so sometimes the documentation lags behind, but we will make sure you to update that.
Maybe you can also say something about the debugging feature that is there in EasyBuild 5, which is also useful when debugging stuff that's failing with Easy. Once you're hitting a failing installation with Easy Build, it will give you a way to jump into this interactive shell.
Mm-hmm.
Um,
Yeah.
So in that sense, it's useful to be able to reproduce a failure interactively, because then you can also use that feature, that easy build feature, to really dig in and figure out what's going wrong. Yeah, that's maybe not easy to demo right now, but
Yeah. So in Easy Build 5, basically, two things were added, that feature you mentioned, and also the last failure log. So instead of searching through the log, it takes you directly to the last failure, which it had.
the last failure thing was already there. But for the failing shell command, you
Mm-hmm.
get the path to the output file of only that shell command and not junk around it.
Yeah.
So that already allows you to zoom in, and it also give you a script to start an interactive shell, which has the right build environment, all the modules loaded, which is in the right working directory, all of that. So you could very easily poke around and see what went wrong. So the combination of that with building in the actual easy build environment, which is what you were showing, is quite helpful. Now, yeah, there's probably room here to make this a bit less painful, because it's a lot of steps as you've shown right now, but it is
Mhm.
possible. All the scripts that we use are there, so you can definitely do it.
And always keep in mind that we are there to help you. You can just reach us through Slack or through Easy Happy Hours. So if you need any assistance, we're there. In case no questions, maybe we can have a look of what's happening in case it went forward. So for some reason, it's still hanging there.
Well, one thing that actually could be the reason for this is, I'm not sure what system you are on here,
Mm-hmm.
but if this is a system with a local mount of easy, we're essentially bypassing that.
Mm-hmm.
Because we're in that build container isolated from the host, we don't require that easy is available on the host.
Yeah.
That does mean it needs to pull in everything that's relevant to be able to do this build. So if that means a slow connection to the mirror server,
Yeah.
things may take some time to actually spin up. That's maybe what you're seeing here.
I do believe that's what's happening, yes, because
Yeah.
it needs to, as we said, easy we stream the software. So in order to build, it needs to check the dependencies, and if they're available, it needs to stream them. So I guess my VM is struggling something with the internet now. Yeah,
Yeah, could be.
reach out
It
to
is
me.
working to some extent, otherwise you wouldn't have gotten this far. But
Yes. So I guess we'll give it some time for.
does anyone have any questions? If so, raise your hand or drop a message in the chat. If not right now, and you would look to do it more informally, we can stop the recording and then do a more open discussion. Yep, it looks like we don't have any questions on record, Richard. So maybe we can stop the recording here.
Yes. So I will stop the recording.